Now let's study the second type of the equations whose general solution we have to find. Now in the second type, the first equation is sin theta equal to sin alpha. Now here we have to keep in mind one thing, that the variable is theta, whose value we have to find out, and sin alpha is nothing but some number. That means it's the sine of certain angle denoted as alpha. So alpha could be any arbitrary angle which is most often would be known to us, and based on that we have to find a general solution for theta, right? So representing on a diagram, let us consider that alpha is some angle, okay, whose sine ratio, that means the y coordinate, right? So the segment on y coordinate represents the sine of alpha. So of course we have theta equal to alpha as the one solution, which is anyways evident looking at the equation. But alpha is not just the one value, and there can be many more angles, as we are going to see. Now if we consider in sequence, there will be another angle which is alpha less than 180 degrees, that is pi. So therefore this angle is pi minus alpha, which will also have the same sign as the sine of alpha. So therefore the next angle in sequence is pi minus alpha. Now moving on, it's clear that we have to complete one full circle and take one more alpha. So that gives us 2 pi plus alpha, which will basically coincide with the original alpha only. Moving on, the next angle in the sequence will be 3 pi minus alpha, and similarly we will have 4 pi plus alpha, 5 pi minus alpha, and so on. Now the question is, how do we generalize all these values in a single result or a single expression? So if we look, there are few observations. That is, first of all, the coefficients of pi are the integer numbers, right? So in the beginning, if you have alpha, then I can write that as 0 pi plus alpha, isn't it? So basically theta is given by first term as n pi, where n is any integer. But after that we have to put the sign correctly, that is whether it is minus or plus, and so on. Looking at these results, we can see that when the multiple of pi is odd, we have negative sign, right? For 1, 3 and 5 we all have negative sign, whereas if we have the even multiple, then we have the plus sign. So therefore we have to develop a formula by which we can alternately produce plus or minus sign based on whether we have an even number or an odd number. So that can be easily done with the help of the function minus 1 raised to n, which we can easily verify. If you imagine n to be an even number, then minus 1 raised to some even power will give us plus 1, whereas if n is if n is an odd number, then minus 1 raised to an odd number will always give us minus 1, which is nothing but the negative sign. So therefore this we have to multiply with the angle alpha, because angle alpha is present in all the possibilities. So therefore this is how we get the general solution of the equation sin theta equal to sin alpha. And it goes without saying that n is an integer. Right? Similarly, let us see the next equation where we have cos theta equal to cos alpha. So once again, let us imagine some tentative angle denoted by alpha. Right? Now here cos means the x component, so therefore this is where we have cos alpha. Now in the sequence you will not get any angle in second and third quadrant because their cos is negative. The next angle that you get will be in the fourth quadrant, which is symmetrically below the given angle alpha. So therefore this is nothing but 2 pi minus alpha. It is just alpha short of 2 pi. Right? So therefore it is alpha, then 2 pi minus alpha. The next angle will be nothing but 2 pi plus alpha after you complete one full circle. So the next angle is 2 pi plus alpha, which has the same x coordinate, that is cos alpha. After that the angle will be directly 4 pi minus alpha and 4 pi plus alpha. So these are the different possible values of theta that we are seeing. Now let us try to generalize this also. How do we generalize? If you look at the first part, we are always getting an even multiple of pi. Nowhere we are getting an odd multiple. So even number can be easily written as 2n, where n is an integer. So 2n will always be an even number. So it is 2n pi. And with each even multiple of pi, we want minus alpha as well as plus alpha. So we want both the signs anyways. So therefore we write plus or minus alpha. That's it. So this is the general solution, that is theta is equal to 2n pi plus or minus alpha, where n is an integer. So this is the general solution of cos theta equal to cos alpha, right, which we have to memorize all these general solutions. Now moving on, we have the third one, that is tan theta equal to tan alpha. Now once again let us consider some angle alpha. Now we know that if we consider the starting angle tentatively in first quadrant, then in the first quadrant tan is positive. So therefore the next probable location where tan will be once again positive has to be in the third quadrant, and it has to be the exact opposite of the given angle, right? Because here numerically the sign will be same but negative, and numerically the cos will be same but negative. Hence tan is once again positive, as we know. So this full angle turns out to be pi plus alpha, because it's nothing but pi is added to the alpha. So therefore the first possible value of theta is alpha. Then the next possible value, as we just saw, is pi plus alpha. After that we have to go further, complete the full circle, and in the first quadrant once again we have overlap with 2 pi plus alpha, which overlaps with alpha. And moving on, the next angle in sequence is 3 pi plus alpha, and so on. So what we are seeing here is we always have plus alpha as one part, and to that we are just going on adding pi and pi every time, right? So therefore generalizing this, we have theta is equal to n pi plus alpha, where n is some integer. So this is the general solution of the equation tan theta equal to tan alpha.